Assalamualaikum warahmatullahi ta'ala wabarakatuh. How are you? Everybody okay? All right. Any question before we start today? I got to look at the thing. Okay. Any question on the consumer surplus? Producer surplus. Okay, semua. All right. Make sure you are able to determine the thing. Consumer surplus and producer surplus to be able to calculate based on the market. The market equilibrium. Okay. All right. Good. So today, what I will do, I will go back. You remember that I told you we need to cover the exponent function. So we do the derivative first. Go to the derivative. We will derivative is chapter 11. So go to chapter 11. We will do the derivative of e function, and then all right, and then we will do the integration of the exponent function. So today, I hope I can do this in 1 hour, and then that will. So go back to chapter 11.2. Okay, we just do the exponent function. We will not do the function. Okay, exponent function. And the basic function, look at the figure 11.6. Now, how does an exponent function look like? It looks like that. Figure A, figure B. Okay, A, B. Look at the function. The function is increasing very fast. All right. You look at the shape of the function. You know, how do we know it's increasing very fast? Look at the second. If you look at the second graph, and you see the derivative of the curve. All right. You look at the derivative of the curve. Look like this. Now look at the derivative at different point. So you see here, it starts with a flatter derivative. That means flatter slope. As x increases, the slope becomes steeper. So from here, as the function increasing, you can also see the derivative is increasing. So we know that the function, okay, the function y equal to e of x is increasing very fast. Okay? Increasing fast. So that's why the line becomes steeper and steeper as x increases. So as x increases, you'll see the function becomes steeper. Okay, become very steep. So that's how an e function look like. Now, what we are interested in, we want to do the derivative. Okay, if you look at the derivative, I look at the derivative. The formula is given that if you have y equal to e to the power of u. So what is the derivative? So the general formula that is given, y equal to e to the power of u of x. Now, u of x is some terms there. U, in example, x squared plus 2, or it can be just x. So you have the general form of the log function. Sometimes we just write it as e to the power of u. We know that u are something x. Now, what is the derivative? You want to take derivative y prime, which is dy dx. That will equal to e to the power of u, and then you have to multiply it by u prime. Or if you want, you can use dy dx. No, I'm sorry, du dx. So that is a general formula to get the derivative of an exponent function. All right. Okay. So example, you look at example 2. Okay, example 2, they give you some functions. Look at example part A. Example 2, part A. So if you have a function, we start a simpler function. Let's say f of x, y equal to e just to the power of x. Okay, we're going to apply that formula. So if you look at this one, it's very straightforward because the derivative is e to the power of x, which is u, multiplied by u prime. Now u prime is u is equal to x, so u prime is just 1. So if you look at the basic function, e to the power of x, the derivative is just simply equal to x. All right? Why? Because if you let u be equal to x, u prime is equal to u prime just equal to 1. So the derivative and the function are the same. Now look at the example number, now we look at example 2, part A. You have what? You have f of x equal to e 4x to the power of 3. So what you do, you let u be equal to the power, which is 4x. Now, what do we need? We need u prime. That means dy du dx. So what is it? It's 12x squared. So that would be equal to the u prime. Now, we put into the formula, then we get the derivative. So the derivative is y prime, or you can use f prime of x. That will be equal to what? You look at the function e to the power of u. Now, what is u? U is 4x cubed multiplied by 12x squared. So that is the derivative of e to the power of 4x cubed. Okay. Now you look at the second example. You have s equal to some function of t, and then you have a constant. So the rules of derivative apply. All right, the rules of derivative apply. That means if you have a constant, the constant will just go with the derivative. So if for part B, okay, part B, what is the u? Or you have here 3t. Okay, t, that means what you need is you need to apply the product rule. All right, because you have a t, okay, and then you have another term multiplied 2, which is e to the power of those things. So we have to apply the product rule. So you just remember product rule. So that example 2 part B, you look at the multiplicative terms. That means you have to multiply product rule by product rule. What is product rule? You have u prime v plus v prime u. All right. But don't confuse with the U power of E. Okay, this is the product rule. All right. So you have the terms together. So you have 3T, which is the U, and then V is E. So you let U be equal to 3T, and then be equal to the E terms, like E to the power of 3T squared plus 5T. So you apply product rule. So what is the product rule? Guna product rule. Okay, what is the product rule? So first U prime. So what is U prime? U prime is just equal to 3. Now what is V prime? V prime, you have to apply the power, the exponent rule. All right. So what is it equal to? It's e to the power of the terms 3t squared plus 5t, and then you have to multiply by the derivative of the power U prime. So multiplied by that, you got 6t plus 5. Okay. So here, okay, V is e to the power of U. Now don't confuse that U with this U. Okay, this U here is the power, which is 3t squared plus 5t. So you take the derivative of that U prime. Right? So V prime is equal to e to the power of U prime. And U prime is du dt, which is the power of the E. So that's how we got V prime. Okay, all right. So you put in everything. What will be that equal? That will be equal to Y prime, U prime, 3 multiplied by V. Okay, that means E to the power of 3t squared plus 5t. And then you have to add V prime, which is what? Which is sometimes, when you do that, you put the U prime at the beginning, 6, 5 plus t multiplied by E, 3t squared plus 5t by U, which is what? U is equal to 3t. Okay. All right. So you can multiply out a little bit, but you don't have to. Just leave it like that. All right. Okay. So that is the derivative of E. So all the rules, all right, all rules of derivative apply. So we don't need any new rules. The product rule, quotient rule, everything will do. So C, okay, where you apply the quotient rule. Or you look at the quotient rule. Okay, any question? Okay. Now application, look at application. Example number 4. Example number 4, what do we have? You have the compound interest problem, future value. Okay, you have initial amount, $100, invest at interest rate 8%, compounded. And then you want to find the rate of growth. Okay, the rate of growth. So the future value is given by ST. All right. So this is on future value. So the formula in the form of the equation is given, and the function, the amount of money that you invest initially equal to 100. it will grow compoundedly, all right, by interest rate equal to 8%. So therefore, it is growing by what? By the exponent function, which is equal to the interest rate, okay, multiplied by time. So that is equal to 100 E 0.08 multiplied by T. So that is our future value. So that is future value. So the growth, okay, the growth of your value of your initial investment 100 will grow by the exponent function because it is compounded. We don't withdraw any money, yeah? Okay, every year what you get in interest you reinvest. No withdrawal. So that is how that will be how much we get after 3 years. Or let's say after 10 years, that means not after at 10 years. At 10 years, what is your future value? So you find S at 10, all right, which is equal to 100 multiplied by E 0.08 times 10. So that is how much you will have after the end of 10 years, not after 10 years, at the end of 10 years. So that is the future value. Now, the rate of growth, what is it? The rate of growth is by looking at the derivative. So you want to have the rate of growth of your money, then I take the derivative as prime t. So you apply the power rule, the exponent rule, okay? Now you have the constant, just follow the derivative, and then you multiply E 0.08 t, and then what is the U prime? U prime is 0.08. And of course, 0.08 times 100, that will be equal to just 8 E 0.08 t. So that is our growth function. How for each year, for every year, how much the money grow. So you can find, all right, if you look at the example, the rate of growth at the end of first year, that will be 8.66. And then at the end of 10 years, that will be 17.8. So to find, I'm sorry, the S prime, to find the rate of growth, okay, find rate of growth of your money or for your investment, then what do? We substitute the T into what? T into what? Into S prime, okay? Don't substitute into S because S is the future value of your investment. Now you want to look at the growth, okay? The rate of growth. So substitute into S prime. So you look at the example, look at part A, part B, okay? That will give you the rate of growth. And of course, example 5. Okay. Any question? So for the chapter 11, you can do some questions on the E. So do question 9 up to 17. So 9 up to 17. And then the application, you do the 44, value. And then we can do one more. 47, that is the marginal cost, and 51. So that will be our, for example, okay. So next, we are going to look at the integral. Okay, the integral of exponent. Okay, integral of exponent. You go to chapter number 12. So exponent will just be like what do you call it? Must be like antiderivative. Okay, you have antiderivative. For 12.3, you have here the integral of exponent function e. So you have to go to 12.3. There is a formula there. Okay, look at the formula, exponent formula. Okay, think of formula. It's the what? It's the derivative of the antiderivative. Antiderivative. The idea is antiderivative. If you know the derivative of the e function, okay, well, how do you get the exponent? All right. So we know the derivative. If you have a u, then what is the derivative? EU, u prime. So if I know this thing here, then the integral will be equal to that. All right. So what you have e u prime dx. What is the integral of that? It will be just eu plus c constant. So that c is a constant. Okay. So you have to have eu u prime. Then we can integrate. That will be equal to eu. Okay. All right. If you look at the first example, example number 1, I want to find the integral of 5 e to the power of x dx. So what is it? Now you look at the e to the power of u prime. I just repeat myself. Okay. And then that is the integral. You must have this thing. So what you do here is I let u be equal to x. Okay. And then what is u prime? U prime is equal to 1. Okay. So do I have the function that I can integrate? I get eu. Okay. So what I have is 5 ex. Yeah. Of course, there is a 1 there. You can put a 1 there. So that will be equal to 5 ex. Imagine 1 there, dx. So this is eu. All right. And that is what? That is u prime. So therefore, our integral will be equal to 5 e to the power of x. Because you have u prime just equal to e to the power of u. All right. Okay. All right. We look at example number 2. Okay. Example number 2, you have a similar situation. You have 2x. You have a function equal to 2x. Then get the integral. So I have here, say y equal to 2x e to the power of x squared. Now you want to find integral of y or integrate y. So integrate dy dx, that is equal to what? The integral of 2x ex squared dx. So what do? You let u be equal to x squared. Now what is u prime? U prime is 2x. So here what you have is e to the power of u, which is x squared. And what is this? This is u prime. So what is the integral? The integral is therefore equal to e x squared plus c. Okay. Right. Any question? So it's just like what we were doing earlier. You have to have the u prime. Okay. All right. So now, let's say I give you the following. Example 3. Let's say I have y equal to 2x e e 3, and then here 4x squared plus 5. Okay, integrate this function here. Integrate y. Okay, wait now. So you have to apply the formula e to the power of u prime. Okay, if you have that form, then you can integrate. Okay, go ahead, do it now. Okay. Now, what is u prime? If you let u be equal to 4x squared plus 5, what is u prime? Okay, what is u prime here?
4.
4.
8.
8 apa? Not just 8. You let u be equal to 4x squared plus 5. Okay, now what is u prime? Bukan 8 ya? 8 apa?
8x.
8x. Okay, you have 8x. U prime is 8x. But we don't have 8x. I have only 3x. Okay, so we have 3x, which is not equal to u prime. So what do? You multiply by what in order to get 8x? Kita multiply by the same principle yang kita dah belajar baru ni ya. Multiply by what? What ratio? What ratio of constant? Kita nak u prime. Okay. What you want is now 8x. So multiply by what ratio? Anybody remember? Takkan tak ada. 60 orang ni dalam kelas ni. I got more than 60 people. I think 60 berapa? 60 or something like that. Okay. What do you multiply that with? The ratio. Ratio of
8/8.
You multiply by 8 over 8. Okay. You multiply by 8 over 8, then you will get 8x. And of course, there is a 3 there. You bring it out. 3 over 8. So you multiply by 8 over 8. And of course, 8 over 8 equal to 1. So what I have now is the integral of 3x. I don't rearrange anything yet. I will do the rearrangement afterwards. 4x squared plus 5. Now the force ini times 8 over 8 dx. Okay, now we do the arrangement. So the 3 over 8, you bring it out of the integral because you will just follow the integral. Then we have 8e 4x squared plus 5 multiplied by 8x dx. So now I have EU, okay, e to the power of u, and then I have u prime. So we can do the integral using the rule. And of course, multiply that by 3/8, 3/8. Okay, so the integral will be equal to, I can write it here, 3/8 e 4x squared plus 5 plus, so there is a 3/8 because you multiply by 8/8. The denominator, you have to make the adjustment. Then you multiply by that constant 3/8. Okay, all right. So remember that. Jangan cepat forget. Okay, so you have to remember, if you don't have the u prime, okay, as what we want, then you can make the multiplication by what? By ratio of the same constant. Okay, in order for us to get the u prime. So make sure do some question on that thing, all right? Because sometimes, you know, these are the things that you have to solve. Right? You have to be able to multiply by the ratio. Okay, all right. So that is exponent of E. So exponent of E, I will give you some questions. Question is 12.3. Okay, so you can do some questions like from number, okay, we can try from number 1. Number 1 to number 13. 1 to 14. Do some, all right? Do some easy questions like from 1 to 4, and then do a little bit more difficult, 5 to 10, and then you look at, you have to multiply by the constant, which is from 12 to 14. Okay, from 12 to 14 to probably you have to make some adjustment, multiply by ratio of constant. Okay, all right, good. Now, go to example number 3. You have here, you are given the rate of change. Okay, so you are given the rate of change. You want to find the value. So we do the integration. All right, so that is the application. So we know the derivative. Now you know the derivative. I want to find the function. In other words, I know y prime. I want to find y. I know, not y prime, y. So that is what we need to do. Need y prime. Okay, y. So here you have the rate of change of the house that cost 200,000 in 1915. So read the thing. Okay, we have the value of the house that costs 200,000, and the rate of change of the value is equal to dVdt, which is given. Now, look at example 3. Example 3 in 12.3. And then what you want, I want to find the value, the function that expresses the value in terms of t. So you have the time t is time in the unit. So unit here is years. So make sure you know the unit of the time. Sometimes, you know, they give you months or day. So that will depend on that specific question. Time is in years, and then the market value is thousands of dollars. So market V is dollars in thousands of dollars. So thousands of dollars. So $1 means 1,000. So you find the function, the value in terms of t. So for part A, I want to find the value. All right. So how do I get the value? So you are given the derivative. So to get the value, you have to integrate the derivative dv dt. Or if they give you, sometimes they give b prime. So same thing. All right. You have the rate of growth. You want to find the value, we integrate. And that is equal to the integral of 15.4 e to the power of 0.077 t. So how do you do this? So you let u be equal to the power. All right. If you let u be equal to 0.077 t. Now what is u prime? U prime is 0.077. Now you don't see 0.077 here. Oh yeah, I got to have the dt. I'm sorry, I got to have the dt. So make sure you put dt though. If I don't put that dt, the meaning doesn't make sense. I mean the expression doesn't make sense. There is no meaning. All right. So I don't have u prime, which is 0.07. What I have is 15.4, the constant given. So how do you get u prime? Kita multiply by what? By ratio of what? Huh? Ratio of what? Somebody. Kita multiply by ratio of what? To what? What is u prime? Prime is 0.077. So you want that. So what you multiply that with? Huh? Multiply by apa? Somebody who get the
200.
You don't multiply by 200. Multiply by apa? You multiply by 200. What do we get? We don't get it. So you don't multiply by 200. What do we multiply that with?
15.4.
No, not 15.4. You need u prime, which is 0.077. Okay, that's the u prime, or the constant that you need, right? You know, you look at the previous example, you have 3x, all right? But what is the derivative? The derivative is 8x. So how do you get 8x? Multiply by 8 over 8. I got 8x, all right? So here, the derivative is just a constant, 0.077. So I want that, and that is not in the function. We have 15.4, right? Which is not 0.077. So how can I make it 0.077 multiplied by what ratio?
0.077 by divide by 0.077.
You multiply 0.077 divided by 0.77. So you just multiply by the value of the constant that you need. Okay, here you need 8. Don't worry about that 3. Okay, you just multiply by 8 over 8. So I have 8 here, and then the 3 over 8 you bring out. Okay, so don't worry about what value we are given. Okay, so in this case here, don't worry about that 15.4. Okay, 15.4 is just a constant. What you need is 0.077. So you multiply by 0.077. And after that, you adjust lah. All right, what we have. So you have, all right, so you multiply by 0.077 over 0.077, because that is u prime, which is equal to 0.07. So therefore, what I have is 15.4, right? E. I will do the extra step. Okay, I don't do yet the simplification. So we do the step multiplied by 0.077 divided by 0.077 dt. So here, that is the derivative that you need, u prime. Then we make the adjustment. After that, you bring the numerator out with the 15.4. So 15.4, you divide by 0.077, because we don't need that. Okay, so what I have now, 0.077 t multiplied by 0.077, which is u prime dt. So that is our function. I have EU, u prime. Okay, this is EU, that's u prime. So what is the integral? So 15.4 divided by 0.777. Kalau tengok buku tu, that would be 200. So we check lah, maybe 200 lah. 200 e to the power of 0.077 t plus c. C is a constant. So that is our value of the property of the house at time t. All right. Okay. Now you look at the information given here. Is this just like when you were doing the marginal revenue? You have a constant here. All right. So in order for you to find the value at a certain time, I need to have the C. Okay, I need to have the C. So we look at that example again, which I did not do, but now you have to do it. Look at the time t. Now look, time t is what? In years. Now what is the beginning time? You look at the question here. T is the time in years from where? From 2015. From or since 2015. Okay, so when you have that, you don't put in the time inside there. You don't put time equal to katakan, you want to find the value of the house in 2025. You don't put 2025 as 2. Okay, you don't do that. You have to do the time in units. So t equal to 0, 1, 2, and so on. Okay. Now, since you have the time, the beginning point is 2015. So that is our 0. That is the initial point. 2015, t is equal to 0. 2016, t is 1. Bukannya T016, you masuk T016 itu. Okay, you don't put 2016. Itulah jadi 2016. Okay, you just need what? The time from some beginning period. Okay, so they mentioned here 2015, the beginning of time. So that is t equal to 0. And then you have so on. So you want to find the value of the house in 2025. So what is the value of the t? T is 2025. Tolok berapa dapat? 10. Okay, so t equal to 10. You don't put t to 0 to 5. Okay, you put t equal to 10. But In order to get that, you have to find the constant C. So you use what? Use the value is given. Use some value given. They call it initial value. So if you look at the question again, you have the value 200,000 at 2015. So we know, okay, at 2015, the value is $200,000. Okay, now $200,000. But the unit of the dollars is in, already they say in thousands of dollars. So kita letak apa? Kita letak 20 ya. So value is 200. Kita divide by 1,000. Okay, because the value of the house, the unit is dollars in thousands. So dollars in thousands, kalau 200,000, it becomes 200. Okay, so the value is 200 at where? 2015. 2015, T equal 0. Jangan letak 2015. Okay, so that is the beginning of the time. So beginning of the time, 0. Okay, and then you just compute what is the value of the time for the corresponding year. Okay, any question on that one? All right, so you have T equal to 0, the value is 200, and that we can find C. So here, using that, you can find C. So to find the value of C, okay, into V. So V is 200, equal to 200, E, okay, E to the power of 0.0770. T is 0 plus C. Now, E to the power of 0. Jadi apa? What is it the value? What is the value? E to the power of 0 is equal, not equal to 0, it's equal to 1. Okay, so what we will have is 1, 200. So therefore, C is 0. Okay, 200 minus 200, the new 1. Okay, times 200, 200 minus 200, that will be equal to 0. So therefore, C is 0. So our value function now, it's more clear. You have 200, E 0.077T plus 0. Itu je. Alright. And after that, you find the value at 10. So at T equal to 10, which is 220.25. Here, 20.25 lah. Okay, you put into here, you get the value. So look at the book. The value of the home will be what? $431,950. Okay, so that is one example. I give you a question. Did I give you question 12.3? Belum ni kan? 12.3. 12.3, we have to do some questions. Oh, tadi. So again here, you do question berapa? Tadi saya bagi 12.2 ke 12.3? 12.3. 12.3 bagilah. So 12.3 do sampai ni, you do a little bit more. Dengan 14 je, 16. Do up to 16. Okay, do sum. Ini do sum je tak boleh buat. So for 12.3 application, okay, application, we do questions application. Compound interest. So you do one problem, compound interest 49. And then you do the population growth 48. And then one more. 52. 52, we do the sales. Okay, all right. Any questions? So that is the E. All right, that is the E. So now kita dapat E tadi. So we go back to the integration. I think when we look at 14 point berapa itu? 14 point something. Yang integration. Ada integration berapa ni? Yang kita ada guna exponent. So go to 12 point. 12.4, 12.5. Application of the integral. No, it's 13.4. Yeah. Okay, we go to 13.4. Then we can do that question. So look at the oil revenue. You know, example number 1. We can do that. Or present value. Okay. So you look at the present value example. Oil tu tak payah tengok. Because we are more concerned with the present value, future value. So you look at example 2, okay, present value. So present value sama juga. When you do the derivative, we want to find future value. When you do this part here, integral, you find present value. So example number 2, I want you to read. Okay, I think that there'll be nothing difficult. Just apply the integration, and then we do one question on that thing. So 13.4, the question that relate to this integral of E, number 3, number 4, and then number 6. Okay, any question? Now I want to give you a group homework. Group homework. We'll do one question. Okay. Give you 3, 4, 6. I want to give you one question. Untuk homework. Okay. Now this is group homework. Kita ada so far group homework baru 1 kan? Okay, this is group homework number 2. 13.4. You do number 7. Okay, first question number 7. 13.4. And then I would like you to do number 24. Okay, 24. 24 is consumer surplus, producer surplus. So these two questions, homework number 2. Group homework. No. Now don't change your group. Okay, maintain the group as per your first assignment. Okay, first I want to sebab homework kita buat satu. Okay, now this is what I would like you to do. Group homework, same group. Okay, same group. If your group friend withdraw, no more. So if one of you is out, so you just do by yourself, right? Don't change any group, same group. Number 2, the same person send, so that I have the same order. Okay, the same person who sent the first homework, now you have to send the yang sekarang lah. Okay, the person who sent the first one, all right, you have to send the second one. So I want the same person, all right? I want the same person to send, so that everything is in order of what I already have. If another person send, then I have to rearrange. Susah juga lah, all right? So is that understood? Same person, because ada dia ni kan yang tak faham lah. Itu yang saya pelik tu. Okay? Masa tanya semua diam. But when things happen, mesti ada dia yang buat benda yang tak betul. Okay, so same person send. All right, the same person. The person who sent the first homework, you also send the second homework. So don't worry who write it. Okay, don't worry who write it. The person who sent the first one also send the second one. And don't change your group. If one of you is already out, and then you will do it by yourself lah. Okay, so don't change group. Yang change group ni pun susah, satu cerita lah. And if you change group, susah lah kat saya. Okay, all right. So don't change group. If your friend already withdraw, don't worry, you do it by yourself. Don't copy lah. Okay, don't copy. I want you to write nicely, especially this one, consumer surplus, producer surplus. Show all the steps. Okay. Now, sometimes some people they are just lazy. All right, I give you 1 week, but when I get the homework, it's just like the homework you copy from somewhere, everything look nice, but the way you write it is you write it in 10 minutes. So spend time now, okay? Spend time, discuss with your friend, make sure you show the steps. Don't just tell me the answers. So the group homework is for you to discuss. Then discuss after the. All right? Okay. Okay, so that's it. I am done with the exponent. And then we are done with the integration. We are done with the derivative. So, kita tengok kalender. Can we go to our calendar? How many? Tengok kalender. We have time. Okay, we have time. So at the end of the semester, maybe we can do some. So today is the 10th. So we have, including this week, we have 3 more weeks. 3 more weeks. So we are on time, all right? We are on schedule. So maybe, from now on, I will go through again the syllabus. Anything that I have not covered that I need to cover, we will do it. Okay, all right. So we now move on to our last topic. our last topic is on the matrix. So we go to chapter. We go back to chapter, early chapter. Chapter number 3. Okay, chapter number 3. Okay, so let's go to the concept. Tengok dah. Ada PowerPoint lagi. Hai, tak ada pula. Pula dah. Tak boleh buka pula. Asal tak boleh buka? Ada sekali. Kan open. Dah lah. Tak boleh buat apa. Kau sini boleh. Oh, patutlah. Dia tak ada kat situ ni. Ini Hasburger. Ini Hasburger. Okey, saya buka textbook. Tengok macam mana. Okay, so now we move to chapter number 4. Chapter number 2. Chapter number 2. Chapter 3. Okay. I just okay. Right. This is a matrix. Now, what is a matrix? Okay, we open the meter. Okay, it's in the book, so we just go by the book. Now, what is a matrix? A matrix is simply an array of numbers. All right, array of numbers. They are arranged in such a way that they are arranged in terms of what? In terms of rows and columns. Row, what is a row? Row that is the line going from left to right. Okay, that is row. So you can look here, row 1, row number 2, row number 3. And then you have the column. Column means the line that goes from top to bottom, vertical. So you have column 1, column 2, column 3, column 4, and so on. So a matrix, they are consisting of numbers that are arranged in that manner, right? According to column and row. So the way to identify an element or a number is by describing it in terms of what? In terms of what row is it and what column is it located at? Okay, so the location is, or the description of an element is by the number of the row and the number of the column. Okay, so if you look at this example, we have 3 rows. Row number 1, row number 2, row number 3. And then we have 4 columns. Column 1, column 2, column 3, column 4. So if I look at that question, that number 20, the element 20 here, the element 20 is described by what? By its position according to the number of row and the number of column. So the number 20 here is located at what? Row number 1, column number 1. Okay. Now, if you look at 31, 31 is element. What is the element? What is the location of that element? 31. It's located at where? It's located at row number 2. What column? Column number 3. Okay. All right. Now, we can also ask, what is the number or the element that is located at row number 3, column number 4, 16. So we are describing the element or the number according to the number of row and the number of column. Okay, any question? So the element of a matrix is described by location. Okay, the number of the row, and the number of the column. Okay, for example, 20. Where is 20 located at? Is the element in what? Is the element or number in row 1? Okay, column what? Column 1. So we describe it in terms of row that goes first, then column will go second. So 20 is the element in the first row, second column. Now, in general, okay, in general, we describe the matrix by A. Okay, that is the matrix A. Now, if you look at the matrix A, this is a general matrix that will consist of how many rows? Kita baca ni, M row. Okay, there will be M row, and then there are N columns. So we call it, the size of the matrix is M by N. Okay, so you have M rows and column. So a general matrix is general. We denote by A, and that size of A is M by N. So that size of matrix or dimension of the matrix. So M by N is the size. Sometimes we call it dimension. Okay, dimension of a matrix. So M by N. And that is equal to, right, equal to, we just having M column. So you have M column. So, no, I'm sorry, M row. So this is row 1, row 2, up to what? Row M. Okay. And similarly for the column, you have N columns. So I have C1, C2, up to Cn. Okay. So if I draw the line, that's row number 1, row 2, row 3. And then here I have row M. Now the column is the one that goes top to bottom. That's column 1, column 2, one more, column 3, and that's column N. Okay, so you have every element, column 1, row 1, column 1, row 1, column 2, row 1, column 3, and so on. And of course, all the elements here. Okay. So how do you describe the element? Okay, we describe the element by the position, like I said earlier, in terms of the row and the column. So you have here A11, A12, A13, up to A1n. So that is row number 1. So all the elements in row number 1, regardless of the columns, you label it A1, 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 A1. So if it is column 1, A11, column 2, A12, and so on. All right. So in short, the element okay, you have M row. So you have M row. So for the row, you have M of them. So we call it I. The general row is I from 1 up to M. And then the column, general number of column, call it J from 1 up to N. Now the element of any matrix, we call it Aij. So here is the element or number in what? In the row I, column J, whatever they are. So example, if I have A11, what does it mean? It means the element in what row? In row 1, column 1. If I have A12, what is it? It's element in row 1, column 2. So the first number is the row. Okay, first number is the number of the row. The second number is the number of the column. All right, so that is the row, that's column. Okay, so A11 is the element in row number 1, column number 1. So if you look at the general form here, I can see here A11 is the one that is the first element. That's the row 1, column 1. A12, row number 1, column number 2. Now, if I look at, I give you something definite. If I have A, row 10, if there are more than 2, maybe put a comma. Macam tu. Sebab banyak sangat. AMN kan? A12, kalau dia sampai 100, jadi pening enggak? So kalau dia too big number, because if I just put A109, or maybe A119, if I don't put a comma, that can be what? That can be row number 1, column 19. Or it can be A11, column 9. So if the number are big, involve 2 digits, so we put a comma. So if I look at this one, what is the location of the element here? It will be row what? Row number 10, column number 9. Okay, any question? So that's how we describe the element in the matrix. So we go back to the example here. The example here, I have what? I have 3 rows, 4 columns. So what is the size of the matrix? 3 by 4. Okay, so M, right? M is a 3 by 4 matrix. So that M equal to 3 by 4. I have 3 rows, all right? And then I have 4 columns, 3 by 4. Okay, so you can have example N, 5 by 6. So you have what? I have 5 rows, 6 columns. Okay. So that is a general notation of a matrix. Any question? So you have M by N, that is what you call the size of a matrix. So another example, you have a C here. Okay, matrix C. All right, what is the size of the matrix C? 2 by 3. I have 3 rows. I'm sorry, I have 2 rows, 3 columns. You have D here. On the other hand, D is equal to 3 by 2. You have 3 rows, 2 columns. Okay, and then I have here a 3 by 3. Okay, B here is a 3 by 3 matrix. You have 3 rows, 3 columns. Okay, all right. Okay, now we go to a few types of matrix. Now, if there is only one row, all right, if there is only one row, what do you call it? We call it a row matrix. If there is only one column, we call it a column matrix. So it doesn't matter what is the number of the columns. If there is only one row, we call it a row. If there is one column, we call it column matrix, regardless of the number of. All right. Now this is the zero matrix. Zero matrix are a matrix that consists of elements all 0. Okay. So all 0, zero matrix. Okay, one more. Tadi tidak tulis. Okay, now you have a number of row equal the number of columns. We call it square matrix. Okay, so square matrix can be A 4 by 4 or A 5 by 5, as long as the number of the row is equal to the number of columns. So we call it a square matrix. Okay, and as we can see just now, you have a zero matrix, and then I have a column matrix, and I have a row matrix. Okay, what else? Now what else? Okay, another thing. This will be our last. You have the row interchange to create another matrix. Then we call B is the transpose of A. So transpose of A will be what? Will be just the row becomes the column, the columns become the row. So if I consider a matrix A equal to 2, 1, 4, 5, 0, 3. So here I have, what is the dimension of the matrix? 3 by 2. I have 3 rows, 2 columns. Now, transpose of matrix, call it AT. What is it? The row becomes column. Okay, so the row will be columns for each of them. So you got 2, 1. Second row becomes second column. So you got 4, 5. Third row, third column. So 0, 3. So now it becomes 2 times 3. So that is transpose of a matrix. So here is the transpose of A. Okay, transpose meaning row becomes column. Or the other way around, columns become row. Sama aja. Alright. Tapi selanjutnya, row becomes column. Okay, all right. Any question? Okay, I think I stop here. If you look at the book, we stop here at the transpose of the matrix, right? And after that, you can look at this example. Okay, nothing difficult. And then next time I will continue with the basic operation of a matrix. Okay, all right. So thank you very much. I will see you again next time. Have a nice doing the homework. Today is Monday. Oh, saya tak cakap lagi due date. Okay, the due date of this homework tadi Today is Monday. So due date, you can submit. Ibu tak apa, alright? Monday, Wednesday. I will give you up to Sunday. Okay, I give you up to Sunday, 5 p.m. Sunday, 5 p.m. Sunday, let me see what is the date for Sunday. Ini 10. Sunday berapa bulan? Sunday 16. Okay, 16 of 1/20. So that is due date. So you can submit earlier, but not after 5 on Sunday. Okay, all right. So I will see you again. Have a nice time. Assalamualaikum warahmatullahi ta'ala wabarakatuh. Transpose of A, due date. Okay.
Thank you, sir.
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 Thank you, sir.